Okay, hello and welcome to Grimeton radio station, Sweden. My name is Fredrik Wiklund and I will be the superintendent today. Next to me I have Anders Törblad, who will be the operator. And next to him is Kai Sundberg, who will be our telegraphist. And behind the camera we have Thomas Alexanderson. And at the media center we have Janne Severinsson. So we're very happy to be live from the radio station on this fantastic day, UN Day, October 24. Before we begin the startup of SAQ, we would like to take you on a short tour to show you the main components of the transmitter. So please follow me. So right next to me is the unique Alexanderson Alternator. This machine was installed in the summer of 1923 and it was made operational in the fall of 1923. So we are talking exactly 100 years. However, the antenna was not ready, so it could not air until October 1924. Inside the alternator is a rotating disc with 488 cutouts, creating a magnetic flux, and that magnetic flux has a frequency of 17,200 Hertz, which is our transmission frequency, 17.2 kilohertz. It is operated by a 500 horsepower, 2,300 volt, during the 1910s, where two-phase was the most have a two-phase induction motor here today. The motor speed is very critical because the transmission frequency is not run at the correct speed. And in order to maintain a correct speed, we can alter the voltage and we can alter the torque. And we have some devices for that I would like to show you. So here is the transformer room. This is where the power enters the building. And you can see that there are 4 wires entering, which is the common for two-phase. So we have 2,300 volts coming in here, and each lead goes to one of these 4 inductors, an invention by Ernst Alexanderson. This allows us to alter the voltage to the motor between 1300 to 2300 volts using a relatively small 500 volt DC current. We also have a set of ordinary 3-phase 400 volt motors. So we have to reconvert the 2-phase back to 3-phase and lower the voltage from 2300 volts to 440 volts in this transformer. This is the auxiliary equipment. Here is a set of generators. These two here generates 500 volt DC used to control the voltage to the main drive motor. Here is another set of 125 to 150 volt DC generators used to magnetize the alternator, for example. Here are 2 cooling fans. One of them is in operation, the other one is backup. The cooling fan's task is to produce compressed air, which is pushed out here into this large manifold and into a set of large contactors, which needs to be air-cooled. Here is the relay corridor where the Morse signal enters the board via this relay and then further to this relay and then further down to these 2 relays. Here's large contactors that are used to control the speed of the drive motor. You will see some major sparks here later on, and you can also see the air cooling coming in here to blow compressed air close to the copper plates here in order for them not to melt from the sparks. So how is the signal reaching the antenna? Let me show you. So this is the magnetic amplifier. The signal alternator arrives here to transformers at the top and is converted from and then led out into the antenna. There are also a set of transductors at the bottom. Alter the antenna tuning frequency when the key is pushed down, the antenna will get the correct tuning frequency. And that's how we create the Morse code. There is also a large adjustable tuning coil that we can operate from the operating panel to fine-tune the antenna. And if we look up into the ceiling, we can see the two copper pipes where the signal is going out to the antenna. The first copper pipe is antenna signal. The second copper pipe is a common ground between the antenna and the transmitter. So let's go to the operating table. So here is a set of really large levers used to turn on the main power, to start the main drive motor, to start auxiliary equipment, etc. In the center is what is called the automatic speed control, a system that can keep the drive motor within correct RPM. And at this part of the control panel, we have a set of gauges, displays showing us the voltage, the speed of the motor, how the automatic speed control is doing. We can also see the power going out into the antenna. We have levers to magnetize the alternator, etc. And there is also a small Morse key we can use when we are tuning and setting up the transmitter. So by that, I think we are ready to start up the transmitter. We have made some initial checks that we have oil where oil should be. However, we have not connected the machine to the power system yet. And take a look, because when we remotely operate the switch, which is in our switchgear, it makes a lot of noise. And if someone is walking their dog, they will be very scared. So we just make this as a safety precaution. Anders is giving me thumbs up. Perfect. So by that, we now have power to the machine. And I will ask Anders to stay here. And I will go and turn on the main power. Anders is ready. And now we can hear an alarm bell is sounding, telling us that something has to be corrected, and that is we have no water cooling and we have no oil pressure. So let's begin by turning on the water cooling system. There are two water cooling pumps, circulation pumps. One is in operation and one is in backup. We're going to use pump number 2 because pump number 1 is not feeling well. It's leaking, so pump number 2 is doing fine. The first thing Anders will do is to fill up the pump house with water, clean water, because the pump cannot pump air. It needs to be full with water. And then he will go to the starter. And it's a Y delta starter, like in the old days. Yep. And we can now see and hear that the motor is running. Next thing Anders will do is to open up the valve for to the circulation system. It's a closed loop system. The water pump is pulling water from an underground pool and pumping the water through several pieces of equipment, including the Alexanderson Alternator, and then the water is returned back to the pool again. So it's a closed system. There is also an outdoor fountain that was used in the old days during really hot summer days where the water cooling system was not enough, so the water had to be air cooled. Today we don't use that on a regular basis, it's more for show. And we can look on the gauge on the wall to see that we have 2 bar or 30 psi cooling pressure. And Anders is now checking that we have enough water in the 2 liquid rheostats that are used to maintain a constant speed of the drive motor when the Morse key is up and Morse key is down. So the next step will be to start up the circulation of the 2 liquid rheostats. And we use a very old-fashioned technique here, namely a small wooden block. And because there are 440 volts on the contactor, Anders is using his protective gloves in order not to get any electricity in his fingers. And now we can see on the screen that the circulation has started. And we can also hear that it's splashing water. Anders is now turning the alarm bell back on again. And now the alarm is telling us that we need oil pressure to bearings of the alternator. And he's turning on an auxiliary oil pump. And the alarm turns off. So the next step now would be to start up the main drive motor. I will ask Anders to be standby at the emergency switch. Good. So now we can see that the drive motor slowly is starting to rotate. The gearbox is stepping up the speed with about factor 3, which means that when the drive motor is turning 1 turn, the alternator is turning 3 turns. So when the drive motor is up to full speed, it will turn with 711 turns per minute, which is equivalent of 2,115 turns, or 25 per second of the alternator. I'm monitoring power gauge to the drive motor, which now 125 volts, amps, I'm sorry, 125 amps. And we can see that it's slowly coming down towards 100 and then further down to 80, which is our next target. Anytime soon, we will have a new alarm. This time, it will tell us that the oil pressure is too high, because the internal oil pump of the gearbox can now produce enough oil pressure, so the auxiliary oil pump is not required anymore. And there it is. So Anders immediately turned off the auxiliary oil pump. And the amperage is going down. We are at 90, maybe. So let's wait until we reach about 80, until we will continue. Right now, the voltage to the drive motor is restricted to about 1,300 volts. And that is because we don't want to overload the motor as it is increasing in speed. As soon as we get to 80 amps, we will increase the voltage with 1,000 volts from 1,300 to 2,200 volts, and the motor will immediately start to build up speed. So I think we are there now, Anders. So first he will turn on the 500 volt rectifier and the 125 to 250 volt rectifier. And now we see the voltage gauge increases with 1,000 volts, and we can feel and hear the motor increasing in speed. And Anders is keeping a close look at the gauge for the motor speed. At the same time, he is raising the water level inside the start rheostat and now in the compensation rheostat to get more power into the motor so that it can reach its target speed, 711. When the motor reaches about 700 RPMs, Anders will magnetize the alternator by closing a knife switch. The alternator will then start to generate a radio wave, but we will also get a feedback to the automatic speed control system, which can take over and start to control the speed of the motor. We are still not connected to the antenna, so you will not hear anything out there yet. Speed now is getting very close to 711, so we have a frequency of 17,200. I think Anders is making some tuning now. I think we could be happy there, Anders, and you will turn on the cooling fan. Very good. So before we can continue and connect the antenna and start to operate the transmitter, we have to turn on the air cooling. We can see the level in the liquid rheostat, and there Anders is turning on the cooling. And for those of us who are in the transmitter hall now, we can immediately feel that the noise level increases a lot. Next step for Anders would be to connect the transmitter to the antenna. And we do that with a motor-operated night switch. And there we are. Now we are to the antenna and on the test with a Morse key to see if we get any power. And I'm looking here at a remote receiver in Holland on my laptop, and I can see that we have signal all the way to Holland at least. So Anders is now pushing the Morse key. At the same time he is operating the variable coil to fine-tune the antenna, and he's keeping a close eye on the meter for the antenna current. But at the same time he needs to have a close look at the frequency so that we are tuning the transmitter to the correct frequency. And we are aiming at 2000 volts to the drive motor, both when the key is up and when the key is down. Ska vi lägga på rensa, tycker du? Ska vi lägga på rensa, tycker du? Ja, det gör vi. So we will turn on our strip shot reader. And we hope that you can hear us now out there. Drobice radio station in Poland. And by that, we have completed our mission to transmit the message. And it's time for us to turn off SAQ for today. So I will ask Anders to begin by turning off the 500 volt or 250 volt magnetization to the generator. And then Anders will turn off the main drive motor. And then Anders will turn off the fan, the cooling fan. And by that, the noise level gets down to more decent levels in the transmitter hall. And the machine is slowing down. We can see that even though we have turned off the power, it will take about 9 minutes for the machine to come to a complete stop. Now Anders is putting the liquid rheostat gates, which you can see on the screen now, back to its original position so we can start up the machine next time again. And the RPM now has gone from 700 down to 500. And now we have a new alarm telling us that the oil pressure is not enough. So Anders is turning on the auxiliary oil pump and is continuing.